Assalamualaikum warahmatullahi wabarakatuh and hi. I am Nur Christina.
And I am Nurafina Nadia.
We are representative for MRSM Johor Bahru. We'll be talking about our project, the Banana Fertilizer Revolution,
A homegrown non-toxic solution for sustainable plant nourishment.
The increasing awareness of the environmental and health impacts of chemical fertilizers has driven a growing interest in sustainable and non-toxic alternatives for home gardening. Commercial fertilizers, though effective in enhancing plant growth, often pose significant risks, including soil degradation, water pollution, and potential health hazards for humans and animals. These concerns underscore the need for eco-friendly and safe fertilization methods that support healthy plant growth without compromising environmental integrity. Commercial fertilizers, while effective in promoting plant growth and enhancing agricultural productivity, often come with significant drawbacks related to their chemical composition. Many commercial fertilizers contain synthetic chemicals and high concentrations of nutrients that can be harmful to the environment, soil health, and human health. The primary issues associated with the toxicity of commercial fertilizers include: Number 1. Environmental contamination. Runoff and water pollution. Excess nutrients from commercial fertilizers often run off into water bodies, causing eutrophication, which leads to algal blooms, oxygen depletion, and harm to aquatic ecosystems. Soil degradation. Continuous use of chemical fertilizers can lead to soil acidification, nutrient imbalance, and the depletion of beneficial soil microorganisms, ultimately reducing soil fertility. Number 2. Health risks. Exposure to harmful chemicals. The presence of harmful chemicals in commercial fertilizers can pose health risks to humans, especially to those who handle them directly. This includes risks of skin irritation, respiratory issues, and long-term health effects from exposure to toxic substances. Food safety concerns. Residual chemicals from fertilizers can accumulate in food crops, posing potential health risks to consumers through the ingestion of contaminated produce.
This study aims to explore the potential of banana peel fertilizer as an effective, environmentally friendly, and cost-efficient alternative to commercial fertilizer. The study will investigate the nutritional composition of fermented banana peel fertilizer, its impact on plant growth, and compare its effectiveness with the commercial fertilizer. By conducting controlled experiment and detailed analysis, this research seeks to provide home gardeners with a viable non-toxic fertilization option that supports sustainable gardening practices and minimize environmental impacts.
For this project, we have obtained 6 objectives. Number 1, to determine the efficacy of banana peel fertilizer as an alternative to chemical fertilizers. Number 2, to study the chemical and nutritional content of banana peels to determine the key nutrients beneficial for plant growth, for example, potassium. Number 3, to create a simple step-by-step guide for preparing and using banana peel fertilizer that can be easily followed by home gardeners. Number 4, to study the environmental impact of using banana peel fertilizer as an alternative to chemical fertilizers, focusing on waste reduction and soil health. Number 5, to ensure that banana peel fertilizer is safe for use in home gardens, especially around children and pets. And number 6, to determine the cost effectiveness of banana peel fertilizer compared to commercial fertilizers. Chemical composition of 6 varieties of fruit peels of the banana and plantain was studied. The results revealed that the varieties did not consistently affect chemical constituents. However, the maturation of fruits involved an increase in soluble sugar content and at the same time a decrease in starch. The degradation of starch under endogenous enzymes may explain the increase in the soluble sugar content. They attributed the degradation of starch to the action of endogenous enzymes, which may explain the increase in the soluble sugar content. They pointed out significant quantities of amino acids such as leucine, valine, phenylalanine, and threonine. Potassium was the most important mineral element.
As for the preparation of banana peels, first, thoroughly rinse the banana peels to remove any dead or pesticide residues. Second, cut the banana peels into small pieces to increase the surface area and facilitate faster the fermentation process.
The fermentation process. Number 1, place the cut banana peels into the container, filling it about halfway. Number 2, add enough water to the container to completely submerge the banana peels. Number 3, seal the container tightly to create an anaerobic environment necessary for fermentation. Number 4, store the container in a warm, dark place for at least 24 hours or up to even 1 or 2 weeks. During this period, beneficial microbes will break down the organic matter, releasing nutrients into the water. Number 5, check the container periodically to ensure the peels remain submerged and to release any built-up gases by briefly opening the lid.
For the experimental subject, Plant A, we treated with fermented banana peel fertilizer, Plant B, treated with commercial fertilizer, and Plant C, controlled plant with no fertilizer at all. For data collection, first, growth measurements. We measure plant height, leaf size, and overall biomass at regular interval. Second, health assessment. We observe and record signs of plant health, such as leaf color, flowering, and fruiting rates. The number 3, soil testing. Conduct soil tests before and after the experiments to measure nutrient levels and soil health indicators.
Next, data and results. We will be discussing about the plant growth metrics. First, we take a look at the chili plant height. This data was recorded over 4 weeks after the use of our fertilizers. Take a look at chili plant A. It showed that plant A has increased 14 centimeters in height after 4 weeks of growth using our banana peel fertilizer. Next, chili plant B showed the highest increased height at 16 centimeters over the period of 4 weeks using commercial fertilizer. Lastly, take a look at chili plant C, which has no use of fertilizer. It is recorded that this plant has the lowest increase in height at 10 centimeters over the course of 4 weeks.
Economic viability. 1 cost per cm of plant height increase. Banana peel fertilizer RM7 6 cm equals RM 1.17 per cm. Commercial fertilizer RM25 8 cm equals RM 3.13 per cm. Control RM 0 per 2 cm equals RM 0 per cm. 2 cost per gram of biomass produced. Banana peel fertilizer RM7 25 g equals RM 0.8 per g. Commercial fertilizer RM25 28 g equals RM 0.89 per g. Control RM0 12 g equals RM 0 per g.
It has been shown that banana peel contains many nutrients and minerals. And that's all from us. May this be a knowledgeable sharing of our project.